Hi girls, this is the video on sorting. There's actually going to be 4 videos on sorting in total, 2 of which I am doing for the weekend for you. So this is the first of 4, 2 of which you'll have for this weekend. So let me talk a little bit about sorting. If I can get my slides to move. It's okay, I don't have many slides. You'll be glad to hear. Okay, so when we think about sorting, we do it every day. So the 2 pictures on this screen are examples of sorting. If you're in a library and you're putting back the books in a particular area, you usually sort them maybe by author name, author first name and surname, or maybe by book title. We would be very capable of doing that if I gave you 20 books and I told you to sort them by title. Alphabetically by title, you would be well able to do that without even having to think. And that is part of the problem with doing sorting in terms of coding, is that we do it so automatically. It can be tricky for us to separate what we're doing into steps that a computer program can understand. So we are going to, on this curriculum, go through 4 sorting algorithms. For the Leaving Cert. So there's 4 that we look at: the selection sort, the insertion sort, the bubble sort, and the quick sort. And you'll see on the slide here, the quick sort has HL. That's for higher level students only. I'm going to do all of them when I'm with you over this 2 weeks. So we'll get them all covered. Then you have the option when you get near the Leaving Cert what paper you're doing, but you'll have this covered. The first 3 are often referred to as simple sorting algorithms. They're straightforward, they're reasonably lacking in complexity. We don't have to worry too much about them, and they should be okay for you to follow. We're going to take time with these though, so I'm not going to rush through them. It might be all we get done really in terms of new content, that and nested loops, before Miss Morad comes back, but that's okay because I want you to understand what's going on really, really clearly. Often sorting and searching come together, and in fact a lot of teachers will do searching first, and if you have the Leaving Cert book, searching comes before sorting. I'm not like that. I'm going to do sorting first, and my reason for that is genuine, because I think the sorting is more complicated. So I'm going to take time and go through sorting really, really clearly with you, I hope. And then searching will be really quick and easy because you'll have done sorting. So the conceptual idea behind it should be straightforward. So because it's a little bit trickier, I want to do it first. So what I'm going to do is, in these videos, we're not doing code. We'll do that in class, but I want to go through the conceptual ideas with you. So we're going to step through that on the whiteboard now. Okay, so here I have a list of numbers that are unsorted. Um, I'm assuming that you understand what a list is, but if you don't worry. It's just a list of numbers. We will, if we need to do lists and list code, we can do that in class on Monday. So this is a list of unsorted numbers. So the very first thing I want you to do is take a pen and paper. I want you to write out this list as it appears on the screen in front of you, and I want you to take 5 minutes just to, not even 5 minutes, it'll take you 30 seconds to sort that list in order, in number order from smallest to highest. Okay, so you should now have this list sorted in front of you, so you can see the solution to this algorithm now. I wonder if I was to ask you to document the process that you used or the steps that you took to sort that, would you be able to do it? Because that's tricky, breaking it down into a set of steps. We're going to do that now, and we're going to do it in a very specific way, and that is for the selection sort. So we are going to talk about how the selection sort works step by step, and it does it in a very specific way. So the way it works is as follows. So bear with me while I do my colors. It breaks the list into 2 sections. It breaks it into the first value and the unsorted rest of the list. So what happens in selection sort, and I might just write that, oh, let me fix that. I'll go again. So this is the unsorted, the yellow bit is the unsorted part of the list, and the blue bit is the header of the list. So this is the top of list, and this is the unsorted part of the list. And what we are working on here is selection sort. So to sort it, we know we need the smallest number at the front, and we need the biggest number at the end and all the numbers in sequence in between. So we understand what we're trying to do. So what we have to do then is what happens in selection sort is once it has the top of the list identified and it has the unsorted parts of the list grouped together, it then searches through the unsorted list, searching for the smallest number. So it searches through, let me pick a different color, the list to find the smallest number. So in this case, this is our smallest number. And when it finds the smallest number, it swaps the top of the list with the smallest number. So in effect, what we end up with, let me change this back to black. What we end up with when this selection sort step one, if we call this step one, is complete, we end up with 17, 24, 63, 45, 85, 31, 96, and 50. So our step one has taken a swap of 85 and 17. 17 is the smallest in the unsorted part and it's put it at the top. It's just literally swapped those two values. So it has literally taken 85 and swapped it with 17. So a swap has occurred. This has been a swap. So how do we do the next step? Okay, so what I've done is I've just put in the text of that list. I've just done a bit of editing and put it in as text because it's easier for you to read. So let's go back. We are going to go dark blue. The algorithm moves forward by 1. So it takes the top of the list here and it takes the unsorted value. And the reason for that, have a think about it. Why do you think that is? The reason for that is now we have, I'm just looking for different colors so you don't get confused. This light blue. We have the sorted part of the list here. We have the top of the list here. And we have the unsorted part of the list here. So this is our unsorted part. Unsorted part. You see why I'm doing the text because my writing is terrible. So now we have 3 different sections in our list. We have our sorted part, we have our top of the list, and we have our unsorted part of the list. And we apply the same algorithm again. So now we search through, I think I used red the last time. We search through for the smallest number in this. So I am going to find the smallest number. It's 31. I'm just double checking because I tend to make mistakes. So this is my smallest and the same thing happens. We need to do a swap here. So we're going to do a swap and the swap will result in me having 17, which is my sorted part of the list. Oh, hang on. 24 is in position. It's no swap is needed. Trust me to make a mistake. Let me go back. At least I caught my mistake. So I said I wasn't going to edit this, so I'm not going to. So what we have in this case is the head of the list, and we're trying to find the smallest value, but 31 would be compared to 24. So we will find the smallest value, okay? But let me go back. So we still have our top, we still have our unsorted, we still search our sorted for the smallest value. But what we do is at that point we check the smallest, which is 31, against the head of the list. So we compare that to 24. So we do a comparison here. And we only swap if this is smaller than this. So is 31 less than 24 false? So the swap doesn't actually happen in this case. It stays where it is because 24 is smaller than 31. So I hope I haven't confused you with that. So we end up with 17, 24, 63, 45, 85, 31, no swap, 96, and 50. Okay, so the algorithm is still the same, but we didn't swap because when we did that comparison, the comparison would have happened in the previous step as well, where we had 17 and 85. 17 was less than 85, so we did the swap. Okay, so then the next step is to take this and run through it again. Okay, so now let's break up our list. So we have our sorted part of the list, which is here. I'm not going to write it in every time now because otherwise we are going to be here all day and I've only 15 minutes on the video. Okay, so this is our oh, sorry, wrong color. This is our unsorted part of the list then here. So we have our sorted part light blue, our head of the list dark blue, our oranges are unsorted, and then we're going to find our smallest, which is 31. And then what we are going to do is we are going to check. So we are going to say, is 31 less than 63? It is true. So we're going to do the swap. So we're going to swap 31 and 63. So we end up then with a list of 17, 24, 31, 45, 85, 63, 96, and 50. So we did, it's true, so we had to do a swap. That meant we did the swap. Our green went in there, and that's the list we end up with for the next step. Okay, so we're getting places. We have now our sorted part of the list is here. That's where we did our last swap, 31. Then we have our head of our list is 45. Then we have our unsorted part of our list is here. And we find the smallest element in that unsorted part of the list, which in this case is 50. And we do our check. Is 50 less than 45? False. So we go no swap needed and it stays the same. So we follow that through to the next step. Okay, next step. We now have a sorted part that is all of this elements here. These are all sorted. Then we have the head of our list, which is here. Then we have our unsorted part, which is here. We find our smallest value, our minimum value, and we do a check. Is 50 less than the head of the list, 85? It is, so we have to do a swap. So the swap that we're doing is 85 is going to go where 50 is, and 50 is going to go where 85 is. So we end up with 17, 24, 31, 45, 50, 63, 96, oh, and 85. 85. So that's our list that we're going to work on for the next step. Okay, so next step then, we have a sorted amount up to here. We have the head, which is 63. We have our unsorted, which are these two values. We have to find the minimum, which is 85. Is 85 less than 63? It's not, so we have no swap. And it stays the same for the next step. Okay, and we go again. So this is the sorted part of our list now. This is the head of our list. And this is the unsorted part of the list. We find the smallest, which is the only thing that's left. And we say, is 85 less than 96? True, so we have to do a swap. So we swap these two values in position. So we end up with a list that is as follows. So our list is 17, 24, 31, 45, 50, 63, 85, and 96 because we did the swap. And our list is now sorted. Green, sorted. What I'm going to do now is just show you that step by step by step without all the colors and where we did the swaps and where we didn't do the swaps. So that'll be the last bit of this. Okay, so here's what we end up with. The blue is our current value, the yellow is our unsorted, and whether we swapped or didn't swap is scribbled out here on the outside. This was the unsorted list we started with. We compared the current value and we searched in here for the smallest, which we found as 17. We did the swap, 17 went at the top, 85 went in at 17, and then we went ahead 24. This is where I got mixed up. So we do the swap because 17 is less than 85. I missed that in the first step, but that comparison happens on each step. So then we have 24. Is that less than 31, which is the smallest in the unsorted? No, so we don't swap, and so on all the way down. You can see for each one whether we swap or don't swap, and then we get to the end, there's no swap because it's sorted. So that is select and sort. What I'd like you to do, it's not homework, it's just to think about now, having seen the video. You're going to be doing this in class on Monday, so if you want to get ahead, you can. could you put together some kind of pseudocode for that algorithm? You might have to replay the video step by step, not code now, just pseudocode and steps that have happened. Maybe just write them out for Monday. And the next video will be on insertion.